maybe. So this
What?
question is like this.
No, no, the 10 degrees is here, the top.
Is here?
Yeah,
Oh.
yeah.
So this is
Yeah.
one meter.
Let me see.
meters.
Wait, let me see.
The
This
height
this is 1 meter.
This is 1 meter.
Yeah.
Pendulum.
Pendulum. You know pendulum?
I don't know.
In a grandfather clock. Grandfather clock. You know clock?
I know clock.
You know grandfather?
I know grandfather.
Do you know grandfather clock? Yes. Yes.
Why?
All right, we'll continue now, guys. The next lesson.
So we have next lesson.
Of course, we have the next lesson.
Oh. What?
But I'll tell you what. No. Underscore x. You have x underscore. Getting closer.
Or effect.
And efficiency. Sorry, Khalifa, you'll have to try next time. We're going to continue now. Yeah.
We shouldn't move something around.
Yeah, but I can't see what address you typed in. You'll have to leave it for now, okay? What you could always do is go to my channel and type in the name of the lesson and search.
Okay.
And then you could see. So, like, there might be a video called, like, question 1. So you could, you know. Okay. Got that? Power and efficiency. You wrote that down?
Sorry, I will send a Happy New Year.
To who?
My girlfriend.
Oh, I suppose you better. She's in China?
Yeah.
You tell her I'm having lots of fun in physics class. Happy New Year.
Okay.
Yeah. Okay, continue.
Continue.
Power and efficiency. Okay, so, a couple of things to do. Imagine you carry 1 kilogram up a hill. So 1 kilogram up a hill. Now imagine 1,000 ants. Ants are the little insect.
Ants, okay.
Yeah. They each carry 1 gram up the hill. 1 by 1. Okay. So on the top of the hill you have 2 piles. Your pile and the ants' pile. You see your 1 kilogram and you see the ants' 1 kilogram. Who did more work, you or the ants?
Ants.
No.
The same.
It's the same. Good. He's got it. It's the same. It's the same because the work is mgh.
Yeah.
The m is the same and the h is the same. But there's something different between you and the ants.
Grams.
Not really that. The ants took longer time,
Yes.
right? The ants took longer.
Yeah.
So we have this new idea of something called power. Power is like work, but it's how quickly you do the work. So power is the work per time. So as a formula, power is work divided by time. So wait, who is more powerful, you or the ants?
You.
Because what's different in your formula here?
Uh-huh.
The time is
Well,
bigger or smaller?
Small.
Smaller.
small.
So you have more power. You do the same work, but you have more power.
Yeah.
And what's the unit? What's the unit here for power? Joules per
second.
second. With joules per second. And that's actually called a watt.
What?
So 1 watt is 1 joule in 1 second. Alright, off you go. Both boxes. Happy New Year. Happy Year of the Pig.
Yeah.
Will you have a party when you go home?
No.
No.
Little party.
A little
with
party.
my homestay.
Good.
Just a barbecue.
That's nice.
And drink.
Maybe.
Oh,
I don't drink one.
I don't know if I believe you, Summer.
yeah. I really because
Someone celebrate I don't come to school tomorrow.
I suppose we'll find out tomorrow.
yeah,
But you smoke.
Yeah,
Okay.
because in the last year or several years.
Yeah.
I drink too much.
Ah.
And this.
You think because of drinking?
Yeah, because
Really?
if you
I think it's smoking.
no, if you drink
Maybe
drink
both.
if you drink too much, you will sleep more late. If I
True.
If I finish the party, maybe it's 3 o'clock
Yes.
or 4 o'clock
Yes.
in the
Sleep
AM.
by 5 and wake up by 7.
It's a problem.
Yeah. There is a benefit, balance in our body. If you don't have too much rest, the balance will be broken.
Yes. So are you going to bed at a good time?
Yeah.
What time?
10 o'clock or 11 o'clock.
And you wake up? At what
Wake
time?
up in 7 o'clock or 6:30.
That sounds good.
I sleep by 11 and wake up by 5:30.
Why so early?
Because I live in Balikali Road. That's Manchester.
I don't think you have to wake up that early, do you?
I have to take my bath,
Ah, okay,
have
okay.
breakfast.
Okay, it takes you a while to get ready. Yeah. Okay, you got this? Yeah. So, when you convert electrical energy into light energy, you have not used any energy. You just converted it. Remember? Electrical into light.
Yes.
But, big but there now, the electrical energy was converted into light, which you want, and heat, which you don't want. So that light has light and heat energy coming out. Yeah. Now you don't want the heat energy, you just want light. So the question is, let's take that light bulb. That's 100 watts.
Okay.
Yeah.
That means 100 joules per second.
Yes.
How much do you think is light and how much is heat? For that light bulb, it's 100 watts, 100 joules per second. So what do you think is, how much is light and how much is heat? So what do we think? So half and half. You're saying 50 joules light, 50 joules heat per second. Okay. What do you think?
Maybe
Like
10%.
10% is
Hot
heat
heat.
and 90%
Line.
light. Okay. And
70%
what,
of light and 30% of heat.
70 light and 30 heat then. Okay. So you said 50-50 maybe, or maybe more, maybe less. So the answer will surprise you. 1 watt is light and 99 is heat.
Yeah.
Yeah.
Yeah, it's I think maybe it's heat is more than the light because
Yeah.
heat.
It's a lot of heat.
Yeah, a lot of heat.
It's a lot. 99 is heat and only 1 is light. So this gives us the idea of what's called efficiency. It's how much energy is useful, energy you want. So in this example, only 1% of the energy is useful and 99% is waste.
Yeah.
Yeah? So as a formula, efficiency is a percentage, and it's the percentage, now please, the word is important, it's the useful output over the total input. And you can use the energy, I'll let you write the formula down. This is efficiency. Does anyone know this Greek letter? Which Greek letter is this? Summer? Do you know which letter this is? Not alpha.
Yeah, I know it's not an alpha, it's not a beta.
It's not beta. It's also not gamma.
Gamma. Sorry, I forgot that. Sorry.
Do you know, Ben?
I don't know.
No. Khalifa?
Sigma.
Not sigma. Eta.
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 Eta. Eta.
Yeah. Yeah. Continue. No. Okay.
Also the light, how to call this one?
Light bulb.
Light bulb is 1000 watt. So the light the light energy is also one volt.
If it's 100 watts,
Yeah.
the light energy will be 1 watt.
Yeah, and
Yeah.
if it's 1000, that
Then
would
it'd be 10 watts.
10 watts.
Yeah.
Just
Just 1%.
1%.
Yeah. Okay, continue.
Yeah.
Got that? So look, what happens if you take the energy and divide it by the time? Then you can change these into powers. But before we do that, you would like the efficiency to be 100%, wouldn't you?
Yeah.
No waste. But because of heat loss, it's always less than 100. Also, if you divide by T, we can change the formula into this. Useful output power over total input power. So you can use energy, work, or power in these formulas, and you get the same answer. Okay. You don't need to write that down, but I think it's good if you write down heat loss means this is less than 100%.
But if
Yeah.
I just want meter heat, like heater,
Yeah, but so the electric heater, if you listen very carefully, you can hear some sound. So maybe the efficiency is 99.99, but it's never 100.
yeah.
Yeah. Now the electric heaters are nearly 100,
Oh.
nearly, but if you can actually hear them, which means you're wasting sound energy. Yeah. So you're right though, Ben. Electric heaters are the closest you can get to 100%, I think. And then on the other side are light bulbs, which are like the opposite. It's nearly 0%. Okay. Continue?
Yes, please.
Yep. So, a boy lifts a 2 kilogram physics book off the ground. He lifts it 1.1 meter, and it takes him 2 seconds to do this. So, here's the book. He lifts it 1.1 meter in 2 seconds. What is the power? Okay, I'll let you calculate that. What's the power?
MGH.
Over?
MGH.
Not MGH. More?
More.
What's the formula for power?
Work times what time?
Work over time.
Yeah.
So
I
okay,
forgot
calculate.
the
Yes,
time.
yes, you did forget.
Yeah. It's 10.791.
10.79 joules. Yeah? M, G,
H.
H. Yeah. Yeah, that sounds about right. Okay? No. Second? What? Yeah. What did you say it was?
10
So,
points.
What it is, Khalifa? It's work
Work,
is sorry.
MG,
power
yeah,
is work over time,
time.
which is mgh over t.
Yeah, T
Yeah.
is T is 2 seconds.
2
It's
seconds.
Right, it's right.
And m is 2, and that's 9.81, and that's 1.1.
Yeah.
So they actually cancel. So what did you get? 10?
10.791
Joules.
Yeah.
Okay. That's, oh, sorry, not joules.
It's
Watts. Okay. Now the next part is he got his energy from his breakfast, and he was 50% efficient. What's his power now? So what you're saying here is, he lifted the book. So the output, power out, is 10.791. But that came from his breakfast. So there's some power that went in. And the power in does not equal the power out. In fact, the power in will be more.
More than power.
Yeah, because he wastes energy. So I tell you that the efficiency is 50%. I want you to calculate the power in.
Yeah, so 20.
Yeah, it'd be about 21.
Yeah.
Yeah, because you have the formula power out over power in times 100 should equal 50. So then that means power in is whatever, 21.5 or something, whatever it is,
582.
roughly. Okay, continue. Oh, sorry, watts, joules per second. Yeah. Okay. Right. A 1,200 kilogram car starts at rest and reaches a speed of 100 kilometers per hour over 10 seconds. If the car was 100% efficient, what's the power of the engine?
What's the power of the engine? Engine.
The machine.
Oh, P. Is P?
No, just P.
Just a P.
So look.
Oh,
Power
yeah.
is work over time.
Yeah.
Okay, do we know the time? Yeah, 10. 10. And do we know the work? Well, the,
half
that's it, a half mv squared, because it's kinetic energy. Yeah. So that's a half m,
1,200.
and then the v we need to convert
It's
because it's kilometers. So it's 100
100
Thousand.
kilometer.
over 3,600.
Because
What do you get?
the final is
Yeah.
46,000
Yeah.
and 13,700.
Watts. Yeah.
Yeah,
Yeah.
maybe. Yeah.
We'll say so.
Yeah.
I'll trust Ben. Okay. If the car was 40% efficient, what is the power of the engine? Now wait, think first. Is it going to be bigger or smaller?
Small.
No.
The
Bigger.
total energy is bigger.
Yeah.
Because
This is the
it's
output.
all an-
Yes. Yeah. Because the engine wastes energy, it needs to have more power because it wasted.
Let me see.
Yeah.
If the car was,
This information is still the same up here,
yeah.
but now it's 40% efficient.
And you also have this.
Yeah.
Oh, okay.
So now we have 46037 over power in is equal to times 100 equals 40. So now what do we get for power in? It would be huh?
11509.5.
Okay, 3 joules. Oh, sorry.
Wow.
What? Goodness sake. Okay. One more example to do, I think. Oh, 2 more examples. Isn't that exciting? Oh no, that's a very hard one. Okay. A pump in a basement pumps oil from a tank at 6 kilograms per second. So, you have, you know, a basement, yeah? In the bottom of a house. Okay. So the basement down the bottom. And you have a pump. And it takes oil from the basement and it pumps it up to a boiler, which is 10 meters, 10.19 meters in height, above the ground. The oil enters the boiler at 2 meters per second. So it's travelling here at 2 meters per second into the boiler. The pump is 75% efficient. What is the power of the pump here? And it's 75% efficient. Okay, I'll do this one here. Oh, and it's 6 kilograms per second. So every second, 6 kilograms goes into the pump and is pushed up to the top. And when it reaches the top, it's going at 2 meters per second. So if you look here, it has 2 types of energy, kinetic and potential. Whereas here it has only kinetic, because the oil was in a big tank and it's not moving. It's at rest. You know, like your oil tank in the basement. No, not moving. So, let's not worry about this. What's happening is this pump is doing work. It's lifting the oil. The work that the pump does is equal to the kinetic energy plus the potential energy up here. Because where did this energy come from? It came from the pump, because the pump gave it some work. So what is that? Well, if we just look at it per second, in 1 second, it's a half v squared plus m, which is g, and then h. That's 60, and that's 12. So that is 72 joules. But that's per second. Every second it's doing 72 joules. So that means the power is 72 watts. But that's the output power, and we want the input power. So we can use the formula output over input
Maybe
times 100 equals, yeah?
maybe the P is 600.
Or did I make a mistake?
Yeah, because 691.
Oh, sorry, thank you. That's 600, isn't it?
Yeah.
Thank you. So that's 612, is it?
Yeah.
Sorry, so that's 612. So that's 612. Okay, that's very different.
Yeah.
So the power input is 612 over 0.75. Right, what's that, please?
It's oh, sorry. I forgot the one.
816.
816 watts. Great. Yeah. Okay. That's kind of a tricky question. Yeah. It's okay.
Maybe.
Should I do another example?
Can I see the question?
Yeah.
Because I missed some.
Because you were texting your girlfriend.
Yes.
Actually, I don't understand the question.
You know what a pump is, or not?
I think pump is something can
Push.
push
Yeah,
the
yeah.
water.
Yeah, push the water, push the oil, whatever. Yeah. So the pump is in the basement, and it pushes the oil up to the boiler. The boiler, it burns the oil. It makes the heat. And it does this 6 kilograms in a second, per second. So, imagine this is the pump, and this is the oil.
Tank.
Yeah, this is the tank. So the oil is not moving. And then the pump takes the oil and pushes it up.
Tank is boom, boom, boom.
No, and also this has two meanings. Two meanings.
What's the?
The other meaning is like a box.
Oh yeah.
Yeah, yeah.
Okay.
So the oil is not moving. So what is kinetic energy? 0.
But in the beginning, just have the H is 0.
Yeah,
So
and the V is 0.
V is 0.
Yeah, because it's in the tank. It's not moving. It's just at rest.
Oh, so here in the beginning,
Yeah.
it didn't have the power, and when he move up, so it has KE and PE.
Yeah.
Yeah. So we don't think about
We don't care about the middle.
the middle.
At the start, it had no energy.
Yeah.
At the end, it has energy.
Yeah.
The reason it went from no energy to energy is because the pump did some work.
Okay.
We don't care how it did the work. Maybe it pushed the oil, maybe it gave it some speed.
Yeah.
You know, we don't care. We just know that it did work. It did work because it took oil which had no energy and gave it as oil with energy.
Okay.
Yeah.
Just focus.
Just focus
on
at the start and
start
the end.
yeah.
Yeah. Yeah. Makes it easier to do.
Yeah.
Continue.
Continue.
Yeah.
Last one.
So one more example here. If we got It takes 30 seconds for a 1,495 kilogram car to reach its top speed of 214 kilometers per hour. What is the power of this engine? So how much power does it have? Okay.
Half 1,000.
Yeah, well let's calculate it. So the formula is power equals work over time,
Yeah.
which is a half mv squared over time.
Yeah.
Now, do we know the m? We do.
Yeah.
Do we know the v?
Yeah.
We do.
We do.
Oh.
And we know the
Oh, okay, so
time.
this is a boring question.
Yeah.
Forget about it. It's not interesting because we know all the
So we
information.
finish?
Ah.
Yeah.
No, this isn't boring. This is hard.
Why?
Oh.
It's
Yeah.
like science.
No,
What
this
was
is
the
this is
meaning
wrong.
question?
This is
Why?
wrong.
Why?
What's the meaning question?
What's the power?
It takes what's power?
Why is this wrong? Because there's the air friction.
Air friction.
Yeah, because I said it's top speed. So it stops at this speed.
Stopped.
Yeah, I mean it can't go any faster.
Oh.
Yeah, I'll do this one. It's very hard. It's very hard. I'll do it. So, will I start the answer?
So in the beginning, it stopped. It stopped or moving. In the
It's not
beginning.
moving.
It just
And then the engine makes it move.
and in the end,
It's this speed.
yeah, is this speed.
Okay, let's calculate.
So
Watch. The answer will be bigger than this.
Why?
Watch, and you'll see.
Okay.
Okay? Right, so look. Here's the car. And it starts off at rest. And what is it? 1495. Okay, and then it speeds up, and then here at the end, 1495, it's going at 214. Can you change that into meters per second, please? Thank you. What's it? 59.4 meters per second.
Yeah.
Why? Because the engine did some work. the engine,
Sorry.
Yeah.
1495 is
the mass.
The mass.
Yeah.
What of 1995?
Oh, sorry, that's just bad handwriting. It's still 1495. It didn't get heavier. So there's some force here.
Yes.
We want to know what this is because we can say work is force times distance.
Yeah.
Now the problem is here you have a drag.
Try.
Yeah,
Yeah.
and here these two are equal in the end. Now you know those formulas I said mgh and a half mv squared? They only work if there's no friction, because the friction makes heat, which is another type of energy. And that's what's happening here. There's more work being done because of the drag, the heat from the drag. Okay, so let's calculate it now. Right, U is 0, V is 59.4, A we don't know, T is 30. I really want to know the A and the S. So let's calculate it. What would be V equals U plus A T. So what's the T here, please, Ben? 59.4 divided by 30. Sorry, I wrote T. Sorry. U, A, that's A. Sorry. Yeah, 1.98. Okay, let's get the S. So S equals U plus V over 2 times 30. So that's just 15 times 59.4. So what's that? Okay. Now the work is the force times the distance. Now we know the distance. It's 891 times the force.
The biggest force is 201 for the speed.
Well, these are all the same.
Yeah.
They're all the same.
They are
So-
the same.
What we could do, if you use Newton's formula, F equals ma. This F is it would be F minus F over 2, because this F stays the same,
Yeah.
but this one, it changes from 0 to F.
Yeah.
So we should use the average.
Okay.
That's equal to M A. So that means a half F equals 1495 times 1.98. So if you multiply this by 2, you get the F here.
Yeah.
So what's the F, Ben?
It's 5274.
5274.
Wait a minute.
What did you get, Ben?
592052.
Like this? 1495, 1.98, and 2.
But my answer is yes, Joel.
Let's see, Ben.
That's right.
Oh, he get the final answer.
Yeah.
Oh, final answer. Yeah.
no.
So you multiply by 891, and now what do you get?
527489.812.
Okay. So that's 1, 2, 3. 1, 2, 3. So that's 5.27 megawatts. But that's not quite finished because I want the power.
Yeah.
So what's the formula for power?
Sorry.
Work over time. So just divide this by 30. What do you get?
175,829.94.
So 830.
Yeah.
So that's 176 kilowatts. Now, if I take this, if you use what you said, which is a half m v squared,
Yeah.
this answer, you can see, is too small.
Right.
This would be the answer if there was no drag.
Oh.
But what happens here is the engine needs to be powerful to give it this kinetic energy and to make the heat
Yeah.
for the drag.
Yeah.
So the answer is bigger than what you think.
Yeah.
So this is a problem with cars. When the car becomes faster, the engine needs to become more and more powerful because
Yeah,
it
so
has two jobs.
So the sports car more like more
Lower.
lower and more how to say that
Smooth,
smooth.
better shape.
Yeah.
Now this is a very hard question. This is way too difficult for the exam.
Yeah.
I think this is not enough, right?
This is too difficult for the exam.
Can I take a picture?
Yeah, but this is recorded, so
I don't want to write.
oh, you're so lazy, Summer.
Yeah. Yeah, everyone will be lazy in some holiday or
Yeah,
some,
but you still have class.
F equals W equals FD.
Yeah.
Is any
Work is force multiplied distance. You forgot this formula?
FS.
FS, same thing.
Okay.
Yeah.
Okay, no. Sorry.
Suddenly, no. Now, let me tell you which will be good for homework here. So, we have class tomorrow, don't we? So,
I think we finish this page and the next page is enough. It's two more.
no,
2, 3. So W, the unit is joule, and the P unit is
what? Yes, true.
I don't like this.
If you do no homework tonight, because it's Chinese New Year, would you be happy to do more homework the next night?
I think it's same.
So you
Yeah, but my question is, if you don't do any questions tonight,
Yeah.
then that means tomorrow you'll have
Yeah.
questions from 4 lessons.
Oh.
Is that okay, or do you want to do some tonight?
just give me something tonight.
Well, you will, yeah. But what about these
Give me
guys?
something.
Okay, fine. So, there's 6 questions here, and there's 7 questions here.
Okay.
So what you could do is 3 and 3. Yeah, and then you can finish them the next night. So you could do, you could do 1, 2, 3, and then you could do 1, 2, 3. And then the next night you can finish.
Okay.
Yeah?
Oh.
You understand? Yes?
You mean now 2, 3,
Ask
and
me.
3.
Now we go celebrate Year of the Pig.
So
So you can do them at home.
oh, just 3.
And 3.
But these 3 will finish.
Then you don't have to do them.
Oh, okay.
You could do the next 3,
Yeah.
or you can celebrate Year of the Pig.
I don't
Your
want
choice.
to celebrate.
Yeah.
That's fine.
No
It's
celebrate.
magic. How did you do this?
I'm very gifted.
Oh.
Oh.
Happy New Year, girl!
God?
Yeah, she's going to be watching this later, right?
Yeah, maybe he will.
Maybe she will.
Yes, he
Yeah,
will.
yeah.
Maybe.
Enjoy your. What will you have?
Sushi.
No sushi.
Just
chicken-
Chinese food.
Chicken chow mein. Sweet and sour pork?
No,
No?
Chinese don't like that.
No.
Yeah, it's really Chinese don't like
Oh, okay.
that. But the
Noodles?
maybe Europeans like
Oh, I like this food.
chicken sweet with
Sweet and sour.
Sweet sour, yeah, but
Chinese people don't.
yeah, but it's European Chinese food. Yeah.
I like European Chinese food.
Yeah.
All right. See you tomorrow, so.
Hot.